Hello. Hello, there we go. That seems like it's working. Hey, I hope everyone's been having an amazing couple days with some amazing talks, getting to see everyone, and all of that. Today, I am going to be talking about how to create a basic chat app using PubSub and Go, which, if you don't know what PubSub is, we'll get into that. Firstly, though, let me introduce myself. I am Tom Camp. I work as a developer relations engineer at Ably, where Ably effectively is a PubSub broker with a focus on data synchronization and reliability of message delivery. And it's actually been such an amazing time here so far, getting to meet people, getting to see people in the flesh, and see talks in person, and even now be able to give a talk where I can actually see people's faces and not just my reflection on a particularly dark screen. But obviously, we've not been that fortunate for the last 2 years to be able to have that, where we've been relying on these internet-based interactions, be it chat apps and games and collaborative things that we can do together to try and substitute for our ability to actually talk to each other and do things in person. And with that, we've obviously seen it become a lot more normalized amongst just general society, having these interactions over the internet where, historically people would be saying, I need to have a meeting with someone, I have to meet them in person, be it fly somewhere to see them or whatever. But these days, a lot more acceptable to now just say, of course, we'll have a video call. Why would we do anything else? And obviously, this has been really interesting to see, but the progression from of the internet, from going from a bit more static and seen as loading web pages and having these static bits of information anyone can access to the real-time experiences that we experience today, has been one that's been going on for many, many years. So today, just to give a bit of an idea of what I'll be talking through, I'll be starting off going through a bit of these basic networking protocols and concepts, just to give a bit of context of how we even have these real-time interactions we have today, and then going into how we can use those concepts to easily make ourselves a nice chat application with the basic functionalities we would expect, with a bit of a summary at the end going into how all of those concepts can then be used for any real-time interactions, really, that we'd want. So, the evolution of communications between devices. One of the initial protocols and design patterns, really, for communication over the internet would have been the request-response method. So it really is what the name says, really. Let's say you have a client and it wants to get some information from a server, let's say a web page or something. That client will send a request to the server saying, hello, I'd like this web page, please. The server will get it and respond. If then the client wants some more information, let's say another web page, it would send another request. Likewise, the server will then respond. This is perfectly fine for static information, such as web pages, or at least components of web pages these days, but it does have some issues in terms of more real-time updates, for example, a chat app, where people are randomly sending potential messages which others will need to receive. Firstly, for every bit of information you need to get, you have the full round-trip time for that message to actually get back. So not only do you have the response, which is really the thing you're interested in, you also need to have a request per message you want to receive, which is not ideal because you've effectively potentially doubled the amount of time it takes to get any data. Likewise, the client isn't aware of how much data, when data is to be available on the server. It doesn't know the rate at which, for example, in a chat app, messages will be published. It could be 5 happening within a second or 5 happening over a week. So in order to make up for this lack of knowledge, it has to either potentially request for updates far too often, or it's going to have to request for updates far too not often. And that's not ideal, because either you're wasting potential bandwidth for messages, because you're constantly going, is there an update? And the server has to reply, no, there isn't an update. You have to go, is there any now? No. Or, likewise, if you're asking for an update every couple minutes or something, you're suddenly getting these delays in terms of potential communication, where you're not seeing the actual messages people have published until minutes after it's actually occurred, which is not ideal. Obviously, people have realized that, and thankfully, very quickly, a very similar concept was founded, except for with a slight tweak, which would be known as long polling, where effectively it follows the same sort of pattern, where the client makes a request to the server for an update of information, along with containing a bit of information in that request, which indicates when it last requested information or what the last response was that it got. The client server can then check that and validate saying, oh, well, is this the same as the update I would be providing now? Has anything changed? If something has changed, great, it can send a response back. But if nothing has changed yet, it can instead just wait a bit and wait for a potential update to return, rather than having this constant requirement for request response for the same information. And then eventually, once there is an update to actually provide, then it can provide that response, which helps considerably with the unnecessary requests, because now we can have the client making a single request and then kind of continuing with something else potentially, whilst the server is then also waiting for an update to return, which helps with our bandwidth and just in general making it a lot more efficient. However, we still, per request, per update we're to receive, going to be having a request, which again means we have that minimum time for an update of the round trip. And likewise, we're still somewhat relying on the client to dictate when an update should happen and how regularly it wishes to check for updates, which seems a bit backwards, seeing as the server is the one who is actually aware of when an update is available. Just to give a bit of a kind of programming basis to these thoughts, if we were to think of, let's say, request response to be a bit more like synchronous programming, where you've got, let's say, your main function, and it makes a request to a function, it waits and waits until that function finishes processing through what is available, and then eventually that returns to the main function, and it can continue. That would be somewhat like the request response if we would consider the client to be the main function and the server to be the function that's being called. Long polling would make it a bit more like an asynchronous function, where you have the request being made to an asynchronous function, or a Go routine for Go, and then they can both kind of continue processing whatever is required. The server, or the Go routine which you have called, can then, eventually, once there is actually an update to provide a response through, say, a Go channel, and then the main function, whenever it needs that information, can try and consume from that and make use of it. Eventually, though, obviously discussing the whole issue with round-trip times and having to have a request per response, real-time subscriptions became more of a thing to act as a solution to this, where, just to give some examples of some real-time subscriptions, there would be like WebSockets or MQTT or server-side events, which would be SSE, where effectively the client still has to send an initial request with potentially some authentication information to say, hey, I would like to connect to you, server or the client or whatever the device is. And then, if the server wishes to actually connect and authentication information is all there as required, it can then agree, have an auth handshake to say, yes, okay, I'm happy for us to establish a connection. From that point then, you can allow for a persisted response between the two. So, for example, WebSockets and MQTT, you have a bidirectional channel for communication, which allows for the client at any time to send an update to the server, and vice versa, the server at any time can send an update to the client, which is perfect because that means for, let's say, our chat app, we now are able to actually have communication occurring as soon as it is available, without any redundant requests being made by the client for information which it doesn't know necessarily exists at that time. We can then rely purely on the server to provide updates when information is available, which makes sense, really. If we were to have a bit of an analogy again to programming, this would be a bit more like Go channels as a concept between, say, two Go routines, where you have two asynchronous entities operating, doing their own thing, and then they can make use of a shared channel or connection, which is then used to be able to communicate. Well, probably would be two Go channels being shared, but the same concept applies where they're able to communicate with one another and share data asynchronously with no absolute lock between the two. So in terms of how really data tends to travel around the internet these days, it tends to be a bit of an amalgamation depending on the type of data. For example, static information such as a static web page, still just very happy to use a request response because there's no need to establish a connection if you're only wanting one bit of information. That it would be a bit redundant and wasteful. But if you want to have a real-time connection, like where updates are happening rapidly or at unpredictable rates, real-time subscriptions make a lot more sense. and work very well for allowing for that in an efficient manner. Obviously, this all works very, very well for one-to-one communication, because one device being connected to another one works perfectly with WebSockets or MQTT. However, the moment that you want to have more complex interactions between systems, where you have fan in and fan out of information, for example, if we're talking about a chat app, the capacity for one client to send a message to all other clients within the chat room, or vice versa, a client to receive all updates from all other clients, suddenly, if you wanted to kind of go for direct connections between everyone, you would be having to handle hundreds of connections per client. Or likewise, if you're needing a centralized thing which is responsible for all chat, you need to make it bespoke and specially made for that communication. So in order to help with all of this complexity of distributed networks and all of that, the publish-subscribe paradigm was founded, which is effectively has the idea that you have an entity in the middle which is responsible for handling the redistribution of data of messages sent into it. So for example, if let's say we have one client which wishes to send hi to a chat room, you would then have it such that it goes via connection, potentially a real-time one, could even be a REST one, into that pub/sub broker, and that broker is then responsible for distributing that to all clients who have indicated they are interested in messages. Usually, the way that this is done is via a concept called topics within a pub/sub broker, which effectively is just a way of saying, for clients to say, I wish for messages I send to you to go to anyone who has indicated they are interested in messages to this topic. So for example, let's say we have a topic which we call chat. A client which wishes to publish a message would send the message to the pub/sub broker, and then also attach topic chat. And that indicates to the broker that any connections which have equally indicated I'm interested in messages to the topic chat should receive this message. And by having this centralized node for which is responsible for the complex distribution of messages, ensuring reliability, ensuring that messages get where they should in the correct order so that everything has a shared state and all of that, is very nice to have taken away from the client and put onto a bespoke system which is intended specifically for that problem, because it means that we can keep our clients lightweight. All they're responsible for as a publisher is sending the message to that pub/sub broker, and then anyone who is subscribed is just responsible for maintaining their own connection to that pub/sub broker. You could create a very similar sort of construct using Go channels, in fact. If you wanted to have fan in and fan out between different Go routines, you could create, let's say, a map of string to channels array, where, let's say, the string in this map would be a topic name, again, chat, let's say. And then you could have individual Go routines add to their channel to the appropriate array within that map. So if I'm interested in messages from the channel topic of chat, then I can just add my channel, which I will be listening to and making use of, to that array. And then you could use something like this function, where effectively this pub/sub type would be able to iterate through all of the appropriate channels in order to then give them the message. It's not a coincidence that we have had this sort of development where we've had developing complexity incorporated into both our programming as well as our communications. As we've developed in terms of our expectations of our devices and the real-time nature of things and the necessity for scale, we're no longer dealing with hundreds of people, we're dealing with millions or billions. We need to be able to distribute our work not over just a server, not just over a server group, but across countries, and on each of those servers having different virtual machines and effectively having all of these tiny components from big scale to the small scale interacting in a predictable manner, both within themselves as well as with all of the other external systems. And in order to have that, we've had to, both programming side and communication side, allow for paradigms which exist and reusable tools such as Go channels, which allow for that predictable interaction between components within your systems. Now we've gone through a bit of the kind of how and the actual technology behind everything and the paradigms behind it all. Let's actually talk about how we actually would make a chat app. So in this case, I'll be using Go and pub/sub. For that, I'll be using Ably as the pub sub broker because it has guaranteed message delivery and things like that, which just make it really easy to use. And what we probably want from our chat app is to allow for usernames so that people can be identified, the ability for users to send messages, to receive messages from a chat room, and then preferably we'll also allow people to see the history of a chat so that if there's been a conversation going on before they joined it, they can see what happened and take part. And also to see who's currently online, so that if I see my friend Beth in the chat, then I can say, oh, hi, Beth, nice to see you. So, firstly, what we need to do is connect to a pub sub broker, because this is going to be responsible for the receiving of messages and distribution of messages. To do that, usually you'd want a method of authenticating who you are to say, I'm allowed to communicate in this group. Usually that would be with an API key or a token. Usually for untrusted entities, you'd use a token because it's revocable and you can have better control over its contents and just generally makes it a bit easier to handle compared to a key where you'd have to do considerably more things to work with it. And we can also say how others should identify us. So for example, this code snippet here, which I will actually give a sample with in a second, is effectively saying we're going to have a client which we are creating, which will authenticate with an API key in this case, and a client ID where we'll insert a username. So if we look here, I'm just going to be very cheeky. I'm not going to actually type it. I'm just going to copy because I do not trust myself. But effectively, if we look here, we've got a main function. Just to give some context on what my setup is at the moment, is effectively just a Go mod, which is importing the Ably client library to make it easy to interact with it, and go.env, which is just allowing me to use an env file so you don't see my API key. Make it bigger. OK. Let's give it a go. There you go. That good? OK, thank you. So here we are effectively just saying, get the environment variable, which will be containing our API key, and then we are going to connect to Ably with the key, with a username which we'll be inputting as an argument, and then this bit here is just basically saying that if we send a message and we're also subscribed to messages from a topic, just don't send it back because we don't need it, we know what happened. So if we also just copy this just to make sure that we are actually correctly instantiating it, so we're just going to be printing out the client ID or username of the user that we've connected with. So if we give that a run now, so I think the bottom, yeah, you should be able to see that, I hope. Let's say I'm connecting as Tom. And there we go. We can see that it's popped up saying Tom, which means that hopefully the object has been instantiated correctly and we have connected. And then obviously, because we've got nothing blocking, it has then quit. It's great. We are now connected to a pub sub broker. Next, we probably want to actually attach to a topic, which is the way we're going to identify what communications are intended for who, and make sure we can actually then publish and subscribe to it. To do that, it really is just a matter of stating the name of the thing you want to connect to. So obviously, you dictate what the name should be. We're going to go with chat because that's what we want. So let's just do this, and that should work. It really is a matter of just saying, yeah, topic is the client.channels.get of chat. Also, just to clarify, it says channels there because topics within Ably is referred to as channels, but I'm trying to not use that because Go channels, probably a bit confusing. So I'm just going to refer to it as topic. Once we've attached, we want to be able to publish messages. So allow for messages from us to be sent to others when we input it in. So we're going to be just using the terminal for this app, just to keep it really simple and lightweight. And at this point, it really is just a matter of eventually taking the input. Whenever someone hits enter, we're going to publish the message, which here is channel.publish of the text. So again, let's get this. And this will act as actually a blocking action. So we'll actually be able to see an output, hopefully. So here, just this one's obviously a bit more, just because I wanted to make it all clean. But effectively, we're still just reading the input we put in, and then removing new line information, and then publishing. And then just having a quick check for if there's an error. We just want to know that something happened. Let's say we don't have internet. And otherwise, we'll just print that we published the message. So if we give that a go, and we go hi, lovely. So obviously this is not us actually being subscribed to the message. This is obviously just happening local at this point. So at this stage, we now want to actually subscribe to the broker in order to receive updates properly from it, like someone anywhere around the world then could with this. So for that, we're again just going to do channel.subscribeAll, or topic.subscribeAll in our case, which will effectively just indicate to the pub/sub broker that we are interested in receiving messages intended for that topic. And then we'll make use of a function which will handle the response. So that is here, where we can, oops, I don't want to have that afterwards. There we go. So here we are, you have topic.subscribeAll, and then we're just going to have a function which will receive the message whenever a message comes through from the pub/sub broker, and we'll just be printing it out with the client ID that would have been specified by any client who's connected, and then the data, which is the actual contents of the message. So let's give that a go with both ones now. So I'm going to connect as Tom in here, and let's connect here, go run Beth. So we see that we've connected as Tom as Beth, and hopefully, if I've not copied incorrectly, we can see on the right we've received the message from Tom. Wonderful, and we can see that we've correctly published that message as well. So, I mean, at this stage, we have functioning chat. Just with a couple lines of code, suddenly we're able to communicate messages with anyone across the globe with potential scale, because that's obviously being handled by the pub/sub broker, and each client is lightweight and able to handle all of this very easily by itself. But as we established at the beginning, we wanted more features than just that. We don't want to just send and receive messages. We also want to know what people are in the chat and when they leave. The good thing with having a pub/sub broker is that, obviously, if it's responsible for all the connections, then equally it's aware of who is there and who isn't. So if it's aware of that, it can potentially try and communicate that to clients as well. So let's say we have a pub/sub broker, and we have 10 clients connected to a topic. The clients can then within their connection, indicate if they want to be considered as part of, say, a presence set, so a set of those who are present. If they do, then the pub/sub broker can remember that and communicate that information to anyone who has indicated they are interested in it. Once they have done that, then equally if they disconnect or explicitly indicate they wish to not be considered as part of that set, then again, the pub/sub broker can communicate that as a message to anyone who has subscribed. So in this case, it's again a case of kind of using the same concept as subscribing from the client side, except for we're just listening to presence events instead. And each of those events will have an action attached to it. So for example, in this case, if we have presence action enter, that is, a client has entered the present set, and the action of presence action leave would be a client has left the present set. So if we were to actually try that now, we can look at here. Actually, we'll also include this. I'll go through it. So what we're doing here is we are entering ourselves into the present set. And this potentially is some optional data you could associate with your client. If, for example, you wanted to include in there, let's say in a chat app, your bio or something like that, you could also attach that to your presence update, which would allow others to get extra context about you joining or leaving the chat. Once you've entered, you probably also want to receive updates, which is that snippet we were looking at in the slides, where you subscribe to the updates and you just check the action and print their client ID or username as required. Eventually, also here, just to handle the case that I'm closing my terminal and stopping execution, seeing as we won't have explicitly closed the connection, it will take about 15 seconds usually for a heartbeat, which is just checking that the client is alive from the pub/sub server to identify that the connection is closed, and thus it should close, take them out of the present set because they're no longer there. So to avoid that little delay in terms of the actual responsivity of detecting they have left, just upon ending the program, we're just also going to explicitly leave the present set. So if we were to run this now, we can, let's say, have Tom enter. Tom is in, Beth joins, and on Tom's side of things, we can see Beth has entered the chat. And then if Beth leaves, Beth has left the chat. So that's great, because using that information, we can then actually identify who's there and who's not. Likewise, you could also make use of, say, a request endpoint on the PubSub server, which contains a just list of the people who are present on a chat. So for example, when you first join, if you want to see who is already there, you can make a request to the server just for a single response, which you can then use to update with, let's say, real-time updates as to enters and leaves, and have a representative state of who is there and who isn't for the entire time you're in the chat. Finally, we want to check history of chat, so what has happened before you joined. This is obviously just a matter of knowing what messages have come before. And how you can do that is in a similar sense as I was just describing for presents, where you could have the server store some present set. You could also have the server have some store for what messages have come before. So if the PubSub broker has these messages stored somewhere, you can also make a request to it to then just get the history, let's say the last 100 messages, and get an paginated result, let's say, which you can then work your way through and reproduce in the chat. So, for example, here we could request for a paginated result from the PubSub broker, and then just iterate through all the pages of that paginated result, saying, for each element, which would be a message, just print it, again with the client ID and the data, and it allows us to retrieve that historical information. So again, if we just grab that from here, and let's put it before we subscribe, just so that we aren't getting duplicate messages, because if someone publishes a message when we're subscribed, and then we call history, we're going to get the message twice, because we'll have requested it in the history at that stage. And if that has been done correctly, if I join, and then I go, hi. There we go. Even before I did that, lovely, we got a whole history of, I'm Tom, hi there, hi, all the various things that I have said effectively over the last time that I've done this. Yeah, obviously not very imaginative with the messages. Yeah, and that's it. And then you can just see that that's kind of then worked seamlessly with what we've got, where you've got the previous messages connecting then to the current messages being sent. And yeah, at that stage, we have a working chat app with history and able to see who's present and able to publish and subscribe messages to one another, all with not really that much code. Like even with all of the extra bits and bobs I have, that's, yeah, kind of sitting at about 82 lines, with most of that being spaces and the imports. So yeah, but obviously all of those concepts that we've been implementing there, with the publishing, subscribing, getting history, presents, etc., that isn't just specific to chat. The kind of premise of PubSub and all of these sorts of tools is that we're meant to have reusable elements which can be used for any real-time interactions. So for example, in a game where you want to have updates as to where players are and what actions players are having, or in tracking food deliveries where you want to see the current location of a delivery driver, or IT devices providing updates, or collaborative projects where you're wanting people to be drawing on a shared canvas, let's say, and you want everyone to be able to see what everyone else is up to. All of these things make use of the same basic concepts of publishing messages, listening to those messages, and seeing what's happened before. So as a bit of an example of this, I've made a bit of a silly game, which is effectively rock, paper, scissors. Please feel free to participate if you'd like, where effectively, normal rules, rock is beaten by paper, paper is beaten by scissors, and scissors beaten by rock. I feel like I've misspelled, yeah, I should have written beaten rather than beats, or put them the other way around, but I hope everyone knows the rules. And effectively, it's that, except for you're all going to be in a giant field, which we can see some people already going around in. Yeah, the top QR code should still be it. And effectively, it's as you collide with players, you will be having that battle of rock, paper, scissors. And you can collect points and see what happens. And, oh no, has the scoreboard gone funny? Let me give it a refresh. Fingers crossed. Okay, oh wait, okay, it's just players without points. Okay, it's scrolling. That's fine, phew. That is allowed. But yes, basically this is using the same basic concepts as what we were just discussing in the chat app before, where you have publishing of messages, where each of the players is sending an update of their current location, their current shape, what their current actions are, etc. And all of the other players are subscribed to those updates and seeing what is happening. There's also information such as present, which we're using to populate the scoreboard to see who is currently there, what their current state is, that bit of information, and then generally making use of history when you first join in order to kind of understand the current state when you first join so you can populate everything correctly. Let's see how the score's doing. Okay, I need to make it so that the high scores go at the top for next time, but it looks like Lulu is decimating, and, ooh, no, okay. It's a strong contest for top place. Okay, this is going quite well, actually. I was worried that it would be too small of an arena for everyone, but I think it's just about working out. Yes, it's definitely looking a bit cramped. But yes, and then, as I was saying, obviously this is an example of it in the game, but it can be used for literally anything. For example, one of my colleagues has made a great project using a canvas for, I think it's like Depict It, which allows you to draw fun images, and people have to guess what the images mean, and then the guesses get passed on, and someone has to draw that. And just generally making use of it for tracking or anything, it's very, very useful. So I'm going to just quickly, I'll probably put this back up for questions and such, but for now I'm just going to flick back for the last few slides. Let's see. Firstly, I want to announce that we're running a hackathon, actually, in the main lounge, which effectively is build something cool with Ably. So if anyone would be interested in that, we have a stall there. It'd be amazing if you can come and talk to us so we can see what amazing ideas you have. And there are some nice prizes. Top prize is AirPod Pros. Wonderful. And there's a bunch of different themes which I'm not actually sure on, but you can inquire, which have £100 Amazon gift cards for. Also, we are hiring, so if anyone would be interested in working in the real-time space, please come talk to one of us in the lounge as well. We would love to chat to you. Even if you aren't, we'd love to hear from you and hear what you think. Thank you so much for listening. I hope everyone has an amazing rest of their day. Thank you. Yeah, any questions? Yep.
I'll just show.
Yeah.
I was wondering, since it's talk about Apply, if you can share what technology you use under the hood for the pub sub, or if Apply built the whole thing from scratch and components.
So a lot of it is custom made. It's based on AWS, using AWS regions to host a lot of it. I think it's largely built in Go, a lot of the back end, with some Node.js and bits which we're trying to remove. And yeah, really it is just kind of different levels of, obviously the basic pub sub of message distribution, and then different other bits of tech in order to ensure guarantees of delivery, ensuring that there's only once delivery of messages and all of that. So I think I definitely have some diagrams again if you want to come check it out in the lounge, and I'm happy to take it through with you. Nice. Anyone else? No? Okay. I mean, if you do have questions, I'll be in the lounge just chilling, so please come find me. But if not, thank you so much, everyone, for coming. I really appreciate it.